After nearly 5 decades in the void, Voyager 2 has just transmitted images so baffling, they're rewriting what we thought we knew about deep space. This incident was a reminder of how remarkable the Voyager mission has been since its launch in 1977. NASA launched 2 spacecraft, Voyager 1 and Voyager 2, on an ambitious mission to explore the outer reaches of the solar system and beyond. These twin pioneers were designed to uncover the mysteries of neighboring planets and extend humanity's vision further than ever before. Outfitted with state-of-the-art instruments of their time, the Voyager probes embarked on a grand tour of the outer planets, capturing breathtaking images and collecting invaluable data that reshaped our understanding of the solar system. From Jupiter's turbulent storms and massive magnetic field to Saturn's awe-inspiring rings, the spacecraft brought the cosmos closer to Earth. Each Voyager carried a unique artifact, the Golden Record, a time capsule intended to communicate the story of our planet to any extraterrestrial life that might one day discover it. Filled with sounds, music, and images of Earth, the record stands as a symbol of humanity's desire to reach out into the unknown. The Voyager's journey through the solar system yielded groundbreaking discoveries that changed textbooks and scientific models. In 1981, Voyager 2 reached Saturn following a trajectory set by its twin, Voyager 1. However, armed with knowledge from its predecessor, Voyager 2 was able to delve even deeper into the mysteries of the ring planet. The spacecraft discovered that Saturn's rings were not static or uniform, but instead dynamic and intricate, featuring kinks, braids, and swirling particles that challenged prior assumptions. These revelations offered insight into the physics of ring systems and led to new theories about how such structures form and evolve. A few years later, Voyager 2 reached Uranus, a mysterious ice giant with an unusual axial tilt of 98 degrees, making the planet appear to rotate on its side. The spacecraft sent back stunning images of the frozen world, revealing 2 previously unknown rings and 11 undiscovered moons. For the first time, humanity had a glimpse of Uranus's icy alien beauty. Voyager 2 also recorded the planet's frigid temperature, an astonishing -353 degrees Fahrenheit. The spacecraft passed through a plasma environment, revealing fascinating insights into Uranus's magnetic field and how it interacts with the solar wind. The field itself was found to be tilted and offset in ways that defied expectations and hinted at complex internal dynamics within the planet. Perhaps the most iconic image captured by the Voyagers was not of a distant planet or mysterious moon, but of Earth itself. In 1990, as Voyager 1 journeyed beyond the solar system, it turned its camera back toward home and took a now legendary photograph, the pale blue dot. From over 4 billion miles away, Earth appeared as a mere 0.12 pixels in size, a fragile speck suspended in the vast emptiness of space. This humbling image forever changed humanity's perception of its place in the cosmos. Renowned astronomer Carl Sagan reflected on the image's significance, emphasizing Earth's vulnerability and the unity it demands from all who inhabit it. As the years passed, the Voyager spacecraft continued their incredible journey, traveling farther than anyone had ever imagined. In 2012, Voyager 1 crossed the heliopause, the boundary marking the edge of the Sun's influence, officially entering interstellar space. Voyager 2 followed in 2018, venturing into the vast, uncharted territory between the stars. Even in this distant realm, the Voyagers continued their mission. Recently, Voyager 2's plasma wave system detected a faint hum originating from interstellar plasma, the first continuous measurement of plasma density in deep space. This discovery provided groundbreaking insights into the nature of the interstellar medium, the mysterious environment that exists between star systems. The interstellar medium is composed of ionized gases, cosmic dust, and magnetic fields, all of which play crucial roles in the life cycles of stars and the dynamics of galaxies. Despite being over 14 billion miles from Earth, Voyager 2 still transmits invaluable data, proving that even after more than 4 decades, these aging spacecraft remain essential tools for cosmic exploration. In 1989, Voyager 2 reached Neptune, the final planet in its grand tour. It became the first and only spacecraft to visit the distant ice giant, capturing breathtaking images of its deep blue atmosphere, swirling storms, and winds reaching speeds of 1,200 miles per hour, the fastest in the solar system. The spacecraft also studied Triton, Neptune's largest moon, revealing an alien landscape covered in nitrogen ice with active geysers ejecting material into space. These findings hinted at the possibility of a subsurface ocean beneath Triton's icy crust, raising questions about whether the frigid moon could harbor conditions suitable for life. Voyager 2 also discovered Neptune's peculiar magnetic field, which is both tilted and offset from the planet's center, challenging previous models of planetary magnetism. These anomalies further supported the idea that ice giants operate under internal structures that are still poorly understood. Originally designed for a 5-year mission, Voyager 2 has far exceeded expectations, continuing to send back valuable scientific data for over 4 decades. Its longevity is a testament to the ingenuity of the engineers who built it. Despite its advanced age, the Voyager 2 team has skillfully managed the spacecraft's power supply, shutting down non-essential systems to keep its critical instruments operational. Operating with less power than a typical light bulb, Voyager 2 still makes monumental contributions to space science. However, as its power dwindles, difficult decisions must be made about which instruments to keep running. Each year brings the spacecraft closer to the inevitable moment when it will fall silent. Yet its discoveries continue to shape our understanding of the cosmos. While Voyager 2 remains a scientific marvel, it is also a symbol of humanity's enduring quest for knowledge. This method was also employed during NASA's earlier K2 mission, which initially discovered the planet. Webb's unmatched resolution and sensitivity make it possible to gather unprecedented information from such fleeting events. The researchers now plan to follow up with additional observations using the telescope's mid-infrared instruments, which will allow them to verify their current findings and further refine our understanding of K2-18b's climate, weather patterns, and chemical composition. Their overarching goal is clear: to search for signs of life on habitable exoplanets, an achievement that would fundamentally reshape our understanding of biology and our place in the cosmos. Beyond K2-18b, the telescope continues to uncover more astonishing data. In another major breakthrough, astronomers using Webb discovered complex organic molecules, akin to smoke or smog, in a galaxy so distant that the light we now observe began traveling toward us more than 12 billion years ago. This galaxy, known as SP41847, exists from a time when the universe was only about 10% of its current age. What makes this finding extraordinary is not merely the age of the galaxy, but the complexity of the molecules discovered. These are not simple compounds like water or carbon dioxide. They are large, multi-atom structures such as aromatic hydrocarbons, molecules commonly found in coal, petroleum, and pollution on Earth. The early appearance of such advanced organic chemistry defies expectations based on current cosmological models, which assumed it would take far longer for stars and galaxies to produce the heavy elements necessary for complex molecules. This raises profound questions about the timeline of molecular formation and the processes that govern early galactic chemistry. The light from this galaxy began its journey less than 1.5 billion years after the Big Bang, offering us a rare glimpse into one of the universe's formative stages. Webb's powerful sensors can now detect not just the presence of such molecules, but also their location within galaxies, revealing that they are not evenly distributed. In SP41847, scientists observe that these organic compounds are present in certain regions more than others, a finding that challenges assumptions about uniformity in early cosmic environments. Intriguingly, this distant galaxy is already nearly as massive as our own Milky Way, with stellar populations that have generated comparable quantities of carbon and oxygen, despite being vastly younger. These observations suggest that galaxy formation and chemical enrichment occurred much more rapidly than previously assumed. As humanity pushes forward into the unknown, armed with increasingly sophisticated tools and a deeper understanding of cosmic processes, we are constantly humbled by the complexity and beauty of the universe. With every new discovery, we inch closer to answering the age-old questions of where we come from, whether we are alone, and what our ultimate destiny might be among the stars. The James Webb Space Telescope continues to function not only as a window into the distant past, but as a catalyst for future scientific breakthroughs. It is only a matter of time before the universe reveals even more of its well-guarded secrets, glowing with renewed brilliance through the eyes of this extraordinary observatory. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. Thanks for watching, and we'll see you in the next.